As we learn more about elements, our next topic is going to be their classification as a metal, nonmetal, or semimetal. Before we look at the periodic table, I want to make you aware that semimetals are also called metalloids. So in some of my texts, well, in your text they call it current text, they call it a semimet. They call them semimetals. In my previous text, they call it metalloids. So in some resources you encounter, you may hear the word metalloid, and just know that metalloids and semimetals are referring to the same elements. So on the periodic table in the slide, they have it a nice visual in terms of the classification. The purple are the metals, so it's mostly on the left. Well, it's almost the whole periodic table, but it's kind of on the left side of the periodic table. Yellow are the nonmetals, and they're kind of on the right side of the periodic table. And then the semimetals go in between the metals and the nonmetals. Now, on an exam, you will not have this color-coded periodic table. Instead, you'll have a periodic table that looks like this. So I want us to be able to look at this periodic table and identify the metals, nonmetals, and semimetals. So on most academic periodic tables, they have a stair-step line, and here I'm just putting it in a red marker to emphasize it. And that stair-step line is very helpful in distinguishing between metals and nonmetals. So to the left of that stair-step line are metals. This includes these two rows here, which if you look, those two rows have been taken out from right here in the periodic table. And if you follow the atomic numbers, you'll see that it goes from 57 down to 58. By removing those two rows, they keep this kind of rectangular structure, but there's also some important information in the columns on the periodic table, and so by removing those two bottom rows, they do keep that integrity, and we'll talk more about the columns in the future. So those are metals as well down here. So they're considered to the left. Then to the right of the line are nonmetals. And there is one element that hangs out on the metal side, but does have all the characteristics of a nonmetal, so it is considered a nonmetal, and that's hydrogen. So in this process of using the periodic table to classify, you have to remember that hydrogen is considered a nonmetal, even though it's on the left of the stair-step line. Now, the semimetals go along the boundary of the stair-step line, except for aluminum, which is element number 13. Aluminum very much has characteristics of metals, so it is classified as a metal, not a semimetal. So the semimetals are boron, and then go after aluminum, go on either side of the stair-step line. So silicon and germanium, arsenic and antimony, tellurium, polonium, and astatine. So they include all of those as the semimetals. So the goal is not to memorize just by listing nonmetals, metals, semimetals, but the goal is to use the periodic table and memorize the orientation of these classifications and locations on the periodic table. So that way we're memorizing less, really, because we'll learn about the periodic table and that will help us classify. So I have a practice. So one thing you could be asked to do is, given an element, identify it as one of these categories: metals, nonmetals, or semimetals. Now, I do have the illustration of the periodic table that has the colors. If you really want to practice this, use the periodic table that I would give on the exam. That would be more realistic. But go ahead and pause and the video. Try to identify which is which of the 6 elements given, and then you can start the recording again because I'm going to go ahead and give the answer. All right, so titanium, letter A is Ti, so it's right here, so it's on the metal side. I'm just going to write M for metal. Chlorine has the symbol Cl. Chlorine is 17 right here. That's on the non-metal side. Hydrogen, which is generally going to be right here on the periodic table. This is the non-metal. Remember, it's the non-metal on the metal side. Magnesium, which is Mg, is right there. That's definitely a metal. Arsenic, which has the symbol As, is right there. So that is a semi-metal. I'm going to write Sm. And then uranium, which might have taken you a while to find. It's element 92 down here. And this is a metal. So our first goal is just to classify them. In the future, when we talk about bonding, we will need to identify elements as metals and nonmetals. So we will be using this in the future. Now, the other thing that we want to make ourselves familiar with are the characteristics of these different classifications. And so here is from your text some of their characteristics. So for myself, just to memorize a list is a challenge. And so what I try to do is connect it to something I feel familiar with. And I feel familiar with aluminum or aluminum foil in my house. And aluminum really does a good job matching the metallic characteristics. Now, let me just back up a step. On your exam, I don't ask you just to list the characteristics. When I'm asking about these questions, it's usually in a multiple choice format or something where I'll have choose all that apply, and I'll have you choose from a list either characteristics that are associated with a metal or a nonmetal, or characteristics that are not associated with a metal or nonmetal. So just keep that in mind. I'm not just going to ask you to list all of the characteristics. But let's just make sure we understand the words. So looking at the metal characteristics right here. So they're solids. The metals are all solids, except for mercury, which is that unusual one of the liquids. But they're solids. And that brings a good point too. Not all metals or nonmetals will have these exact characteristics. These are in general the characteristics that we would find in those classifications. So back to metals. Solids. Metallic luster, that just means kind of a shine that you get with a metal. Pliability, the third one down. Malleable and ductile. Malleable, you can look it up, but it means you can put into shapes, like you can form shapes. Ductile is the property of being able to be pulled into a wire so that you can have wires. Conductivity means it conducts, and heat. Metals conduct both heat and electricity. Density and melting point for metals are usually high, and what they like to react with, in general, metals like to react with nonmetals. If you think about aluminum, it matches all of those things. And that's what just helps me a little bit, is to try, if I get in a bind, to think, okay, does aluminum have that characteristic? That might work for you, might not. It's just a connection or something that I found helpful. Now, in nonmetals, the prefix non really means like not, like it negates. So if they're nonmetals, it means they're not metals. And so if we look at their characteristics, a lot of them are just the opposite of what a metal is. Now, their physical states, there are some solids, are some gases. There's one liquid, bromine, but so they have really all the states. They tend not to be shiny. They tend to be dull. Although we will get to see in lab iodine, which is a non-metal solid, and it's a little sparkly, so it's kind of cool. So that's what I mean when I say that not all of the metals or non-metals will have all of the characteristics. This is general. Pliability, they're brittle, so you can't shape them and form them wires. They are non-conductors, which means they don't like to conduct heat or electricity. Another word for something that does not conduct is an insulator. Their density and melting points are usually lower, and nonmetals will react both with metals and with other nonmetals. So they have a little more reactivity in terms of that. So those are the characteristics. And then semimetals has one characteristic that I want you to be aware of, and that is their properties, which are in between metals and nonmetals, make them ideal for being semiconductors. And so a semimetal's claim to fame is a lot in being a semiconductor. I always like to point out, so we have Silicon Valley in California. It's not because silicon is mined or found there naturally. They named it Silicon Valley because that is where a lot of the tech industry settled, and silicon was an important semi-metal used in the semiconductors. So I think, and if I understand correctly, and I don't know a lot about semiconductors, but it has to do with the semi-metals will conduct electricity maybe without getting hot. So metals, I think, when they conduct electricity can get hot. And it's something like that makes them more valuable in the electronics than just a regular metal. So let's look at a couple questions that would be more like what you would have to do with the properties. So go ahead, read the question, pause, get an answer, and then start the video again, and I will answer. So which of the following properties is not, so it's not a characteristic of a metal? And the answer is that it reacts with other metals. That is not true. Metals in general are good conductors of heat. They do usually have higher melting points and are malleable, but reacts with other metals? No, they react with nonmetals. All right, so let's try one more. It says, which of the following properties is not characteristic of a nonmetal? So go ahead and pause. Sorry, I didn't give you time to pause. Pause, answer, and then I'll answer the question. All right, so not a nonmetal. Insulator of heat, low density, ductile, reacts with metals and nonmetals. So nonmetals tend to not be ductile. They are good insulators of heat, which means they do not conduct heat. They have a lower density, and they do react with both metals and non, but they tend to be brittle. So in general, what you need to take away from this video and focus on is using the periodic table that I give on the exam. You need to be able to identify which elements are metals, nonmetals, or semimetals. Secondly, you need to, given a list of properties, be able to classify them as properties of metals or as nonmetals.